question 1a, work out 0.7 multiplied by 0.5. So I'm going to times 0.7 by 10 to make it 7. I'm going to times 0.5 by 10 to make it 5. And then I'm going to do 7 multiplied by 5, which is 35. It makes my life a little bit easier. But now I need to reverse these two multiply by 10s. So if I divide it by one of those 10s, we get 3.5. And then if I divide 3.5 by the other 10, we get 0.35. So the answer is 0.35 on the answer line. 1b, work out 5/6 divided by 3. So the first thing we need to remember here is 3 can be written as a fraction over 1. So we're going to keep the first fraction 5/6, but we want to change this to a multiplication. So instead of 3 over 1, we're going to write its reciprocal 1 over 3. Because its reciprocal is its inverse, and that means we can use the inverse operation to division, which is multiplication. So now we're going to do top times top, bottom times bottom. 5 times 1 is 5. 6 times 3 is 18. 1c, work out 27 divided by 0.6. So what I'm going to do is multiply 0.6 by 10 to make it 6, but because it's division, I have to do the same to the other side. So 27 times 10 is 270. So now I'm going to do 270 divided by 6. So 6, 12, 18, 24. Remember, by doing this, I'm saving myself some brain space. So 6 is into 27. 1, 2, 3, 4 gets us to 24. Then from 24 to 27 is a remainder of 3. 6 is into 30. 1, 2, 3, 4, 5. No remainder, so the final answer is 45. This is also the answer to our division sum because we've done the same to both sides. So it's still an equivalent sum. We don't need to reverse it for division. So we're going to put 45 on the answer line. Question 2. Solve 2x is less than 26. So solving inequalities works the same way as solving equations. We're going to use the inverse operations. So this is 2 multiplied by x. So the inverse would be to divide both sides by 2. When I divide the left-hand side by 2, that leaves me with x. The inequality symbol needs to stay the same and match. And then when I divide the right-hand side by 2, 26 divided by 2 is 13. This whole thing now goes on our answer line. So x is less than 13. If you don't put that less than symbol, you're going to lose that mark. Question 3. Work out the value of 3 over 2 squared. Give your answer as a mixed number. So remember, when we're squaring a number, we're multiplying it by itself. So this is the same as doing 3 over 2 multiplied by 3 over 2. We know how to multiply fractions. It's the top times the top and the bottom times the bottom. 3 times 3 is 9. 2 times 2 is 4. Currently we have an improper fraction because the numerator is bigger than the denominator. It wants our answer as a mixed number. So we see how many of the bottom number go into the top. So 4, 8, 12. So 2 whole lots of 4 fit into 9. That gets us to 8. So we have a remainder of 1. So it's 2 1/4. And 2 1/4 goes on our answer line. Question 4. ABC, BD and BE are straight lines, and we can see them in this diagram here. Angle EBD, so EBD is this angle here, is 5 times angle ABE, so ABE is this angle here. Angle DBC, this angle here, is 3 times angle ABE. Work out the size of angle EBD. So we don't have any numbers here, but we do have relationships between the angles, and we've been given a relationship for both of these angles in relation to this angle here. So let's call angle ABE x. If angle ABE is x, then EBD must be 5 times x. So this angle here is 5x, And then DBC must be 3 times x, which is this angle here. Now we do know that angles on a straight line sum to 180. So we're going to add these angles together. So we have x, add 5x, add 3x, and what we would expect is an answer of 180. So 1x plus 5x is 6x, plus 3x is 9x. So now, if we solve this equation for x, we'll be able to substitute that value into this expression to find that angle EBD. So the opposite of 9 times x would be to divide by 9. So 180 divided by 9 is 20 degrees. Now that I know x is 20, I can substitute it into this expression for the angle EBD. So for angle EBD, we've got 5x, which is equal to 5 times x. We know x is 20, so 5 times 20 tells us that angle EBD is 100 degrees. And you're going to pop that on your answer line. Question 5. 2 prime numbers are multiplied together. The answer is an even number between 50 and 60. Complete the calculation. So we're going to put 2 prime numbers in here that give us an answer between 50 and 60 when we multiply them. So first of all, let's list a few of our prime numbers. 2, 3, 5, 7, 11. Let's deal with those for now. So if we want our answer to be an even number, we need an even multiplied by an odd. That's the only way we're going to get an even answer. Or we could have an even multiplied by an even. But this one is asking for 2 prime numbers being multiplied together to give an answer between 50 and 60. Now the only even prime number is 2. So if we're to use 2 times 2, that only gives us an answer of 4. So that's not going to work. So the only combination we have left is even and odd. The only even prime number we've said is 2. So now we need to find an odd prime number, which the rest of them are, that when we multiply it by 2, when we double it, we get an answer between 50 and 60. So the biggest one I've listed so far is 11. If I double 11, I get 22. That's not going to work. The next prime number is 13. Double 13 is 26. That's not between 50 and 60. The next prime number is 17. Double 17 is 34. So that's not going to work. The next prime number is 23. Double 23 is 46. The next prime number is 29. Double 29 is 58. Now this option would work because 58 is between 50 and 60 and 29 is odd and prime. So if we pop 29 there and 58 in the answer box. Question 6. Andrew and Bruce share some money in the ratio 5 to 6. Andrew and Bruce. Bruce gets £96. So Bruce, his part of the ratio in real terms is worth £96. Andrew gives 1/4 of his share to Carl. Bruce gives 2/3 of his share to Carl. How much money does Carl receive? Okay, so we know Bruce gets £96. To be able to give some of Andrew's money to Carl, we need to find out how much Andrew's got. So I'm just going to bring this down. So we've got Andrew to Bruce in a ratio of 5 to 6. We know that Bruce is worth £96. So this piece of information is going to help us figure out what we need to multiply this ratio by to figure out Andrew's share of the money. So we need to figure out what we multiply by. So we're going to do 96 divided by 6. 6, 12, 18, 24, 30, 36. This is just to save me brain power. So 6 into 9 is 1. To get from 6 to 9 is a remainder of 3. 6 into 36, 1, 2, 3, 4, 5, 6. No remainder, so the answer is 16. So we've times by 16 here. So if I do that on the other side of the ratio, 16 times by 5, 5 times 6 is 30, 5 times 1 is 5, plus 3 is 8. So Andrew gets £80. So now we can then share this money with Carl. So Andrew gives 1/4 of his share to Carl. So 1/4 of £80 is that £80 divided by 4. So Andrew's going to give Carl £20. Bruce gives 2/3, and 2/3 of his amount, so 2/3 of £96. So the first thing we're going to do 96 divided by 3. So 96 divided by 3, that's going to be our first sum. 3, 6, 9, 12. 3's into 9, 3, no remainder. 3's into 6, 2, no remainder. So when we divide by 3, that's £32. However, that's 1/3. We need to now multiply by that 2 to get 2/3. So 32 multiplied by 2 is 64. So Carl gets 20 plus £64. 4, 8. So he gets a total of £84. Question 7. We've been given a product of prime factors with one of the powers, one of the values missing. So 2 to the power of a multiplied by 3 multiplied by 5 squared equals 600. Work out the value of a. You must show your working out. So there's a couple of different ways you could do this. I'm going to start by working out the part of this product of primes that I can calculate. So I'm going to do 3 times 5 squared, which is 3 times 5 times 5, which is 3 times 5, which is 15 times 5, and then 15 times 5 is 75. So if I substitute that in, I have 2 to the power of a multiplied by 75 gives me 600. So by using inverse operations now, I can find out what that 2 to the power of a must be equivalent to. So the inverse of multiplying by 75 would be to divide by 75. So I'm doing 600 divided by 75. I'm going to count up in 75s. So when I get to 150, that's 2 of them. So now I'm going to count up in 150s because I'm going to find that quicker to get to 600. So 150, 300, 450, 600. Each of these is worth 2 lots of 75. 2, 4, 6, 8. So 600 divided by 75 is 8. So 2 to the power of something is equal to 8. So now I'm going to deal with my powers of 2 until I find out what that number is going to be for a. So by powers of 2, I mean 2 to the power of 1 is 2. 2 to the power of 2, 2 times 2 is 4. 2 to the power of 3 is 2 times 2, which is 4, times by 2 again, which is 8, and I'm going to stop here because I have a match here on the right hand side. So 2 to the power of a is equal to 2 to the power of 3, so a must be 3. Question 8. Expand and simplify fully. So remember, everything on the outside of a bracket gets multiplied by everything on the inside. So 5 multiplied by 3x is 15x. 5 multiplied by positive 4 is positive 20. And it's important that we put that addition symbol there for a positive number when we're dealing with expanding and simplifying. Moving over to the next bracket, negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. A negative times a negative is a positive, and then 2 times 1 is 2. So now it's a case of collecting like terms. So we have 15x subtract 2x. It's really important that we use a sign in front of the term to determine whether we're adding it or subtracting it to any other terms that we have in common. So 15x take away 2x is 13x, and then positive 20 add 2 is positive 22. So 13x add 22 goes on my answer line. Question 9. Erica tries to sketch the graph y equals 1 over x with x not equaling 0. So y equals 1 over x is a reciprocal graph, or an inverse proportion graph. You may have heard of it that way. So this is Erica's sketch. We need to make 2 different criticisms of her sketch. So we've got criticism 1 and criticism 2. So the first criticism I'm going to make is about this point here. So the y equals 1 over x, the reciprocal graph, it never touches the y or the x-axis. It always approaches and gets nearer and nearer, like here, but it never touches it because there's a break in the curve when x equals 0. That's what this is all about. So the first criticism I'm going to make is it touches the y-axis. That shouldn't happen. It should never touch the x or the y-axis. The second criticism I'm going to make is where the second part of the graph is. Yes, there are two parts to this graph, but this part is usually in a different quadrant. By quadrants, I mean these 4 sections. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. This section here is usually in quadrant 3. So actually, it needs to be reflected over the x-axis. But you don't have to go into that much detail. You can simply say that the curve in quadrant 2 should be in quadrant 3. There we go. You could say the curve in the top left should be in the bottom left. You can mention that it's wrong, but your criticism is that it's gonna be in the wrong quadrant if they were plotting the right graph. Question 10. Sunita is X years old. Beth is 1 year younger than Sunita. Joel is double Sunita's age. The mean of their ages is 5. How old is Joel? So again, we're going to form and solve equations here because we haven't been given enough numerical values to be able to do this otherwise. So, Sunita is X years old. Beth is 1 year younger than Sunita. So Beth is X subtract 1 years old. And then Joel is double Sunita's age. So Joel is 2x years old. The next piece of information we're given is that the mean of their ages is 5. To find the mean, we would have added these ages up and then divided by 3 for the 3 ages that we had. So I'm going to do that with these algebraic expressions for each person. So let's start by adding them. So x, add x minus 1, add 2x. So we would have added those together to get x plus x is 2x, plus 2x is 4x, and then subtract 1. So this is the sum of their ages, but we would have divided that by 3 because we have 1, 2, 3 ages, and then that would have given us this mean of 5. So now we've formed an equation. So if we solve this equation for x, we can substitute the x value into here for Joel and find out his age. So the first thing I'm going to do is multiply by 3 to eliminate this fraction. So when I multiply the left-hand side by 3, I'm left with 4x subtract 1. When I multiply the right-hand side by 3, 5 multiplied by 3 is 15. The next inverse operation I'm going to deal with is to add 1. And by adding 1, it eliminates the negative 1 on the left-hand side. So the left-hand side becomes 4x. And then when I add 1 to the right-hand side, 15 plus 1 is 16. The final inverse operation to find x, instead of 4 times x, I'm now going to divide by 4. So when I divide by 4 on the right-hand side, 16 divided by 4 is 4. Now I know that x equals 4, I'm going to substitute this into the expression for Joel. So this is Joel's age. Okay, so we said 2x, which is 2 times x. We've just found out that x equals 4. So that's 2 times 4, which equals 8. So Joel is 8 years old. Question 11. The Venn diagram represents 100 items. So all of the numbers inside this diagram must add up to 100. 11a, write down the probability of A intersection B. So this symbol is the intersection, and the intersection is this middle section here. So write down the probability that it's A intersection B. It's in both A and B. Well, there's 13 in that centre part, and we've been told it's out of 100, so our denominator would be 100. Part B, work out the probability that it's not A. That little dash there is the complement and it means not. So everything that's not A. So we can't have anything that's in the A circle, but we can have this 48 and this 11. So 48 plus 11 is 59. Again, that's our numerator out of a total of 100. So we pop 100 on the bottom of our fraction. 11C, work out the probability that it's work out the probability that it's A union B. So that's A or B. What this means that it's in the circle A and the circle B. So there's anything that's in these circles is included with that union symbol. So we have 28 plus 13 plus 48. We're not including that 11 because it's not inside any of those circles. So when we add those together, 28 plus 13, that's 30, 41. 41 plus 48 is 89. So we have 89 out of a total of 100. Question 12A. A multiplied by 10 to the power of n is a number in standard form. Complete the inequality for the value of A. So that's the value of this number here. So what we need to remember is that part of a number in standard form has to be between 1 and 10. So it can include the number 1, but it can't include the number 10. It's got to be between 1 and 10. 12B. B times 10 to the power of n is the number 7,200 written in standard form. Work out B times 10 to the minus n. Write your answer as an ordinary number. Okay, so let's start by writing 7,200 in standard form. So 1, 2, 3. So it would become 7.2 times 10 to the power of 3, because we're going to have divided it by 1,000. So that's 7,200 in standard form. But they want us to find B times 10 to the power of minus n. So B is 7.2, n is 3, so minus n would be minus 3. So now we're going to find out 7.2 times 10 to the power of minus 3. So the way we're going to do this is you've got 7.2. We need to move all of our numbers 3 places. 1, 2, 3. So actually it's 0.0072. Remembering that negative powers in standard form moving the opposite direction. Question 13A. Here is a number machine. So we have an input, some operations that we apply to that input, and then the output. So the solution that we would get when we follow through the machine. Show that when the input increases by 2, the output increases by 2a. So let's work through this function machine now, this number machine, and see what it is that comes out of it. See what expression we get. So we're starting with x. We're multiplying by a, and then we're adding b, which gives us y. Now, if the input increases by 2, we can do that as x plus 2 because that's 2 more than x. So let's go through this machine again, but now with our input as x plus 2. So we're starting with x plus 2, multiplying by a. These brackets are important because we've got 2 terms to multiply by a. Then we add b to get our output of y. So let's expand this one, and then we can compare it to that first expression that came out of our number machine. So a times x is ax, a times positive 2, positive 2a, we have the plus b, and then it equals y. So when we look at these two equations that have been formed from the number machine, the difference between this first one and this second one is the plus 2a. That's what shows us that the output, the answer, increases by 2a because we've added 2a to it by adding 2 to that input. 13b, f of x equals kx squared, where k is constant. Kai says that f of 6 divided by f of 2 is equal to f of 3 because 6 divided by 2 equals 3. Is he correct? Show working to support your answer. Okay, so let's work out what f of 6 is. So f of 6 means substitute 6 where there's an x in this equation here. So we've got k times 6 squared, which is 36k. Let's find out what f of 2 is. So f of 2, substituting 2 in instead of the x. So k times 2 squared, which is 4k. Okay, now let's work out f of 6 divided by f of 2. So f of 6 divided by f of 2 equals 36k divided by 4k. We can divide top and bottom by k. So we're doing 36 divided by 4, which is 9. Okay, so f of 6 divided by f of 2 is 9. Let's figure out what f of 3 is. So k times 3 squared, which equals 9k. So f of 6 divided by f of 2 is 9. F of 3 is 9k. So chi is not correct. They don't match. Question 14. Here is a list of 11 whole numbers in numerical order. The lower quartile, median, upper quartile and highest value are missing. So if these are in numerical order, then the first missing value must be the lower quartile. The next one must be the median, then the upper quartile, and then the highest value. So I'm just going to make a note for myself there. So the median is 2 times the lower quartile. The upper quartile is 2.5 times the lower quartile. And then the range is 2 times the interquartile range. So the interquartile range is the upper quartile subtract the lower quartile. So I've made a note of that there as well so I don't lose my train of thought. So if these numbers are going in numerical order, then the lower quartile has to be 9, 10, 11 or 12. That's the numbers between 8 and 13. Now I'm going to start by using trial and error with a value for the lowest quartile, because the lower quartile is included in 2 of the 3 calculations. So if the lower quartile is 9, then the median would be 2 times 9, which is 18. So if I look at the median box, the lower quartile can't be 9 because the median has to be greater than 19. So the lower quartile being 9 is not an option. Now let's start with the lower quartile equals 10. So if the lower quartile equals 10, then the median must be 2 times 10, which is 20. So that would work. The upper quartile would be 2.5 times the 10, which is 25. So when I get to here, this can't be 25. They're in numerical order. It's got to be bigger than 28. So a lower quartile of 10 does not work. Let's try a lower quartile of 11. So the median is 11 times 2. So that would work. The upper quartile is 2.5 times 11. Well, 2.5 times 11 is 22 plus 5.5. So that's 27.5. We're dealing with whole numbers. So that can't be the value. So the last one that we've got to try is the lower quartile being 12. So if the lower quartile is 12, the median is 2 times 12, which is 24. That would work. The upper quartile is 2.5 times 12. So 12 plus 12 plus half of 12, 20, which is 30. That works. So let's go with a lower quartile of 12, a median of 24, an upper quartile of 30, but we've still got this highest value to figure out. So the highest value we can find if we know the range, because the range is the biggest takeaway, the smallest, and we know what the smallest value is. But to find the range, we need to use the interquartile range. So the interquartile range is the upper quartile 30, subtract the lower quartile 12. So 30 subtract 12 is 18. The range is 2 times that interquartile range. So it's 2 times 18, which is 36. So to find the range, we would have done the highest value, take away the smallest value. So if we add the smallest value to the range, that will tell us what the highest value should be. Question 15. ABCD is a trapezium. All 4 sides are different lengths. AB is parallel to CD and the diagonals intersect at X. For each statement, tick the correct box. So triangles AXB, so AXB, so this triangle here, and CXD, so this triangle here, are similar. This is true because they share this point here, and if we were to move the points A and B down, they would lay inside, they would lay on XD and AC somewhere inside this triangle here because of that parallel line. So that's true. Triangles AXD and BXC are congruent. So AXD, BXC are congruent. Congruent means exactly the same. This is not true because we've been told all 4 sides are different lengths. So AD is a different length to BC, even though that these 2 lengths and these 2 lengths we're not too sure about. So that's not true because all sides are not the same. And if it's congruent, all 3 sides would be the same, not just the 2 sides of each triangle. Angle ADB equals angle BDC. ADB, BDC, these 2 angles. This is not true. There is no rule that would make these angles be equal. And then the last question, area of triangle ABC is the area of triangle ABD. So we would do half times the base times the height for the area of the triangle. They each have AB in common. So what we've got, A, B, C. Let's highlight that to make it a bit clearer. A, B, C and A, B, D. So they've got the same base, AB. They've got the same perpendicular height because X is where the diagonals intersect. So yeah, the areas of those 2 triangles would be the same. Question 16. Solve the simultaneous equations. 2x subtract 5y equals 13. 3x add 4y equals 8. So let's call this equation 1 and equation 2. So I'm going to make the y terms of each equation equal in this instance. So I'm going to multiply equation 1 by 4 because that's the coefficient of y in the other equation. So 2x times 4 is 8x, negative 5y times 4 is negative 20y, and 13 times 4, 13 times 4, 4 times 3 is 12, 4 to 4, 52. Remember to multiply everything in the equation. I'm now going to multiply equation 1 by 5 because that's the coefficient of the y term in the other equation. So 3x times 5 is 15x, positive 4y times 5 is positive 20y, and then 5 times 8 is 40. So now my y terms are the same. They both have a coefficient of 20, but they have different signs. Because the signs are different, I need to add these equations together. By adding these equations together, it's going to eliminate the y term and make it so I can solve for x. So 8x add 15x is 23x. Negative 20y add 20y is going to be 0. 52 add 40 is going to be 92. So now we're going to divide by 23. So we're doing 92 divided by 23. So what we got? 23, 46, 69, 80, 92. 1, 2, 3, 4. So x is equal to 4. Now I know that x is equal to 4. I can substitute this value back into one of my original equations to calculate the y value. I'm going to use the bottom equation because I'm dealing with a positive and I don't have to worry about negatives. So using equation 2, which is 3x add 4y equals 8, I'm going to substitute x equals 4 into the equation. So 3 times 4 add 4y is equal to 8. 3 times 4 is 12. So 12 add 4y is equal to 8. Now we're going to solve this equation for y. So the first thing I'm going to do is subtract 12 from both sides. So we have 4y equals, and then when I subtract 12 from the right hand side, we get negative 4. 8 subtract 12 is negative 4. The last step is to divide by 4. It's the inverse of timesing by 4. So y equals negative 4 divided by 4, which is negative 1. So x equals 4, y equals negative 1. Question 17. A solid hemisphere has radius x. A solid cylinder has radius 3x and height x. The surface area of a sphere is 4 pi r squared, where r is the radius. Work out the ratio of the total surface area of the hemisphere to the total surface area of the cylinder. Give your answer in its simplest form. You must show you're working out. Okay, let's deal with the hemisphere first. So surface area is all the way around the outside. So we would have 4 pi r squared divided by 2, because that's the surface area of a sphere, but then we halved it for the hemisphere. That gives us the curved part of the shape, but then we need the flat circle at the base there, which would be add pi times radius squared. We know the radius is x, so we have 4 pi x squared over 2 plus pi x squared. 4 pi x squared over 2 can be simplified to 2 pi x squared, and then 2 pi x squared add pi x squared is 3 pi x squared. So that's the hemisphere. Let's deal with the cylinder now then. So to find the surface area of the cylinder, we need the area of the two circles. So we're going to have 2 pi r squared, because pi r squared is the area of a circle and we've got 2 of them. Then we also need the circumference multiplied by that x length there. Circumference is pi times diameter multiplied by x. So let's stick in what we know here. So r is 3x. So we have 2 pi 3x squared plus the diameter. If the radius is 3x, the diameter is double that, which is 6x. So we have 6x times x, which is 6x squared, and we've got that pi there as well. Let's simplify this a little bit further. So 3x squared. 3 squared is 9, x squared is x squared, plus 6 pi x squared. I've just written that slightly differently because pi is still a number, so we can use it as a total coefficient. Now let's simplify this. 2 times 9 is 18, so this is 18 pi x squared plus 6 pi x squared, which gives me 24 pi x squared in total. So let's write this as a ratio. The total surface area of the hemisphere, 3 pi x squared, to the surface area of the cylinder, 24 pi x squared. We can divide both sides by x squared. We can divide both sides by pi. So we're left with 3 to 24, and they're both multiples of 3. So if we divide by 3, we get 1 to 8, and that's what goes on your answer line. Question 18, we have an inequality here. Circle the possible value of x. So at the moment we've got the cube root of x in the middle. So what I'm going to do is I'm going to cube the inequality to get rid of that cube root. So I'm going to have 6 cubed and then 7 cubed. So 6 cubed, 6 times 6 is 36. 36 times 6 is 216. So it's 216, 7 cubed. 7 times 7 is 49. 49 times 7, 7 times 9, 7 times 4, 343. This may only be a 1 mark question, but don't be afraid of working out. Make sure you get the correct answer. So the value of x is somewhere between 216 and 343, but not equal to either. So it must be 290. Question 19. Work out how many 5-digit odd numbers can be made using these digits once each. We've got 1, 2, 3, 4, 5 digits. So we can't list them, and it would take a while anyway. So here we've got an even, 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 odd, and odd. This is important because we want to make an odd number. So if we want to make an odd number, then that last digit has to be odd. Okay, so we've got digit 1, 2, 3, 4, 5. This must be odd. Okay, if it's not odd, then we haven't got an odd number. So here, we're going to work systematically this way through the number. So there are only 2 options for it being odd. So we're going to put a 2 there. Now we're going to figure out how many options there are for this digit here. Well, it can be even or odd. That's not a problem. But we've already used one odd number. And we've used 1 out of the 5. So there's only 4 numbers remaining. When we go to this one, we've used 2 numbers. So there's only 3 remaining. When we've come to this one, doesn't matter if it's odd or even. We've used 3 numbers. So there's 2 remaining. And then when we get to this final digit, we'll have used 4 of the numbers. So there's 1 remaining. So we need to multiply those numbers together. So 1 times 2 is 2, times 3 is 6, times 4 is 24, times 2 is 48. So there are 48 possible options. Question 20. K, L and M are weights. Both of the scales balance exactly. How many M weights are needed to balance 1 L weight? Okay, so what have we got here? So this scale is balanced, so 3 K weights is equal to 1, 2, 3, 4 L weights. Okay, and then on this scale, 1 K weight is equal to 1 L weight plus 2 M weights. So at the moment we can't really compare these because we've got K and 3K. So let's multiply this one by 3. So 3K equals 3L plus 6M. So now we can compare them. So this 4L must be equal to 3L plus 6M. So when we subtract 3L, 1L is equal to 6M. How many M weights are needed to balance 1 L weight? Well, the answer is 6. Question 21. Express x squared subtract 6x subtract 15 in the form of x subtract a or squared subtract b, where a and b are integers. So this is completed square form. So we're going to complete the square. So inside the bracket goes half of the coefficient of the x term, this thing here. So half of -6 is -3. Now I'm going to square this value. -3 squared is 9, and then subtract it from the outside of the bracket. I still have to take into account the -15, and then we're going to simplify. So x subtract 3 squared, -9 take away another 15 is -24. And I'm going to pop that on my answer line because it's now written in the form requested. So we've completed the square. Question 22. A equals root 2 and B equals root 18. Match each expression to its value. One has been done for you. Okay, so to start off with, what I'm going to do is I'm going to simplify B. So root 18 can be simplified to 2 times 9, which is root 9 root 2, which is 3 root 2. So that's my B value simplified. So let's start substituting in some values. So A squared, so root 2 times root 2 is going to be 2. Already matched up for us, so we're just checking we know what we're doing. A plus B, root 2 plus 3 root 2. 1 root 2 plus 3 root 2 is 4 root 2. So we're going to match A plus B to 4 root 2. A times B, so we're doing root 2 times 3 root 2. So root 2 times root 2 is 2. So we're going to do 3 times 2, which is 6. And then B divided by A, so 3 root 2 divided by root 2. We're going to cancel those roots. B divided by A is 3. Question 23. Write 0.13 recurring as a fraction in its simplest form. So I'm going to start by expressing x as 0.1333, and obviously it would continue. Now I'm going to get another version of x, but I want the decimal to match as much as possible. So I'm going to get 10x to start off with. So 10 times x, if x is this, would be 1.333, and that would keep going, that would keep recurring. Now, what I'm aiming for is for them to match on the right-hand side here after the decimal point. They don't at the minute, so what I'm also going to go with is 100x. So x times 100 would be 13.333 recurring. So what we can see with these two values here is that we have the same digits exactly recurring after that decimal point. So these are the two versions I'm going to use. So 100x subtract 10x is what's going to happen now. So 100x subtract 10x is 90x. So then 13.3 recurring subtract 1.3 recurring. Well, the 0.3 recurring is going to cancel out, and 13 subtract 1 is 12. And now it's a case of solving for x to write it as a fraction. So x equals 12 over 90. We want it in our simplest form, so that's 6 over 45. Both still in the 3 times tables. So that's 2 over 45 divided by 3. 50. 2 over 50. Question 24. Points P, Q and R, and R's coordinates are given there, form a triangle. PQ is a horizontal line with P on the y-axis, which is here. Angle PRQ is a right angle. The gradient of the line PR is 2. Work out the coordinates of Q. So first of all, we're going to work with this piece of information here, knowing that the gradient of PR is 2. So if I was to draw a line down there, the gradient would be the change in y divided by the change in x. The change in y we don't know yet, but the change in x, if this is on the axis, it's at 0, and then across to here is to 8. So actually this distance is 8. So we will have done something divided by 8 to get this gradient of 2. So 8 times 2 is 16. So that tells me that that distance there is 16. If this distance here is 16 and the y coordinate there is 22, 22 subtract 16 is 6. So it means that Q has a y coordinate of 6. So now it's simply a case of trying to find the x coordinate. So we're going to find the x coordinate by finding the equation of the line RQ. So we were told that the gradient of the line PR is 2. Well, the line RQ is perpendicular to PR because of this right angle. So it has the negative reciprocal gradient of PR. So if PR's gradient is 2, then the gradient of RQ is -1/2. It's the negative reciprocal. So now we can form an equation for the straight line RQ. So y equals -1/2 x add c. Now we know a set of coordinate points on this line RQ. They've given us r. So let's substitute those in. So x equals 8 and y equals 22. That's from that r coordinate there. So y equals 22, x equals 8. So -1/2 times 8 is -4. If we add that 4, c must be 26. So if we rewrite this equation, y equals -1/2 x plus 26. So this is the equation of the line RQ. So now we can use this equation and the part of the coordinate we know for Q to find out the x coordinate. We know what the y value is. We're looking for the x value to complete that coordinate. So we're going to substitute y equals 6 into this equation here. And it's because we know Q's got a y coordinate of 6. So 6 equals -1/2 x add 26. If we subtract 26, so 6 subtract 26 is 20. And then we're going to divide by -1/2. So when we divide by -1/2, it gives us that's -20. So when we divide by -1/2, it gives us +40. So x is +40. So this is the x coordinate. So Q has an x coordinate of 40 and a y coordinate of 6. Question 25. Show that 4 times sin 30 subtract tan 45 divided by 2 cos 30 can be written as tan x, where x is an acute angle. So we need to use our exact trig values here. How you generate these is up to you, whether you use the table, whether you use the hand method, whether you just remember them. But we need the exact trig value for sin 30, tan 45 and cos 30 initially. We'll also need to know what tan x equals, but we can deal with that towards the end of the question, where x is an acute angle, so x needs to be less than 90. So that's worthwhile bearing in mind. So exact trig value of sin 30 is 1/2. The exact trig value of tan 45 is 1. And the exact trig value of cos 30 is √3/2. So now we're going to substitute these values into this calculation. So we've got on top 4 times 1/2, that's 4 times sin 30. Subtract tan 45, which is 1. And that's all going to be divided by 2 times cos 30, and cos 30 is √3/2. Okay, so 4 times 1/2, that's 2, subtract 1 on top. 2 times 3√2 becomes 2√3/2. So now we can simplify the top and the bottom further. 2 subtract 1 is 1. 2√3 divided by 2, leaves us with √3. So this calculation is 1/√3. Now I know from my exact trig values that 1/√3 is the exact value for tan 30. If you'd have generated it using a table, then you would have been able to recognise that value if you didn't know it off by heart. So 1/√3 is equal to tan 30. 30 is less than 90, so that's an acute angle. So it can be written as tan x when x equals 30. And then we've done that question. Question 26. A circle, centre O, has a circumference of 20 pi centimetres. Q is a point on the circle and OPQR is a square. It being a square is important because we need to remember the properties of a square. So the ratio of the perimeter of the square to the circumference of the circle is equal to root A to pi, where A is an integer. Work out the value of A. You must show you're working out. So if we want the perimeter of the square, we need to know the length of the square so that we can then find the perimeter. We've already been given the circumference of the circle, so we've been given the second part of that ratio there. So let's start thinking about how we can use the circumference of the circle to find out the lengths of this square. Well, O to Q, so OQ is the radius of the circle because it tells us that the centre is at O. So if we're going up from O to Q, that must be a radius. Okay, we know that the circumference is 20 pi, and to work out the circumference, we would do pi times the diameter. So if the circumference is 20 pi, then the diameter must be 20. If the diameter is 20, then the radius is half of that, so the radius must be 10. So OQ is 10. Now I can use that information to find out the side length of the square. Now remember, 4 equal sides for a square. So I'm just going to take this bottom right angle triangle of the square. Let's call these two sides X. They are both equal length, so I can call them by the same letter. And I'm going to use Pythagoras to find out what X should be. So the shorter side squared, so X squared plus X squared should equal the longer side squared. So we're forming an equation right now. So X squared plus X squared is 2X squared. 10 squared is 100. So X squared is equal to 50. So X is equal to the square root of 50. Now I'm going to simplify the square root of 50. So that can be 25 times 2, which is root 25 root 2, which is 5 root 2. So this is now the side length for the square. So I can find the perimeter. The perimeter is all the way around the outside of the shape. I've got 4 equal sides, so the perimeter of the square is equal to 4 times 5 root 2, which will be 20 root 2. So now we're going to use the circumference of the circle and the perimeter of the square because that's what it asks for in our ratio. So let's write them as a ratio as we currently know them. So perimeter of the square first, 20 root 2 to the circumference of the circle, which we know is 20 pi. So now we're going to simplify this ratio and we're going to try and get it into this form. So I can divide both sides by 20, which leaves me with root 2 to pi. So the right hand side of the ratio matches. The left hand side matches in terms of we've got a root, and that tells us that actually the value of A must be 2. Question 27. A journey has 2 stages. So we've got distance, speed and time for stage 1 and stage 2. Show that the average speed for the whole journey in kilometres per hour is this expression here. So if we want the whole journey, we need the total distance and the total time. Speed, distance and time. If we're working out speed, we need total distance and total time. So the total distance is 30 add 30, which is 60 kilometres. There's kilometres here, and let's just check that it matches the units we're using for speed, so that's good. The total time is 30 over A add 30 over B. So to find speed, we will do distance divided by time. So speed equals the distance, total distance of 60, divided by the time. So we're going to deal with this fractional part first. So it's an addition of two fractions. So we need a common denominator, then we can represent it as one fraction. So it's going to be 60 divided by, I'm going to multiply this fraction by b. So it will be 30b over ab. And then I'm going to multiply this fraction by a. So it'll be 30a over ab. Now we have a common denominator. We can write them over that common denominator. So 30b plus 30a over ab. So now it's a case of simplifying this as far as we can go. So we're dealing with a division. So let's write this as 60 over 1. So we can think about dividing fractions. So when we divide fractions, we're going to keep the first the same. And then we're going to find the reciprocal of this. So we're going to flip it upside down. And now it becomes a multiplication, which we can then write as 60ab all over 30a add 30b. Remember, it becomes a multiplication because the reciprocal is the inverse. Now we're going to simplify. So we can divide 60 by 30 and we can divide the two coefficients here by 30. So let's divide by 30 where possible. So that becomes 2ab on top and then a plus b on the bottom. And then when we compare this to this, it matches. So we've done what they asked us to. We've shown that the average speed for the whole journey in kilometres per hour is the expression 2ab over a plus b.